So this problem is about solving for a reactant in solution. So there are a few key formulas to keep in mind here. The molarity of something is equal to the moles of solute divided by the volume of the solution. And something else that's important is that the moles of something, let's call it A, is equal to the mass of that substance in grams divided by its molar mass in grams per mole. Now, most commonly we'll use this formula like this. We'll do mass times 1 on the molar mass, because it allows us to use dimensional analysis to make certain that we've got our units correct. Okay, so because this is about a chemical reaction, I can tell that because it says a reactant, it's really important that I have a balanced chemical equation. So I'm immediately on the lookout for, where's my balanced chemical equation? Because from my balanced chemical equation, I'm going to get my mole ratio, right? And your mole ratio is the only way that you're able to convert from moles of one thing into moles of another thing. So that's why I always, whenever we're looking for a reactant or a product, I'm always on the lookout for a balanced equation in case I need that. So it says sodium hydrogen carbonate, also known as sodium bicarbonate or baking soda, can be used to relieve acid indigestion. Acid indigestion is the burning sensation you get in your stomach when it contains too much hydrochloric acid, which the stomach secretes to help digest food. Drinking a glass of water containing dissolved sodium bicarbonate neutralizes hydrochloric acid through this reaction, and there's our balanced reaction. Okay, and you'll see that it makes carbon dioxide gas. And so it says the carbon dioxide gas produced is what makes you burp after drinking the solution. So suppose the fluid in the stomach of a woman suffering from indigestion can be considered to be 150 milliliters of 0.053 moles per liter hydrochloric acid solution. What mass of sodium bicarbonate would she need to ingest to neutralize this amount of HCl? So what I'm going to do is this. I'm going to go from volume of HCl to moles of HCl. Then I'm going to use my mole ratio, and I'm going to go to moles of sodium bicarbonate, and then finally I'm going to go on to grams of sodium bicarbonate. So that's how I'm going to do it. And you can see the key thing here is I have to get the moles of one thing in order to be able to convert to moles of another. So it doesn't matter, whenever I'm going from amount of one thing to amount of another, I've always got to go through moles. So let's see how we're going to do this. It was 150 milliliters of hydrochloric acid, and the concentration was 0.053 moles per liter. So 150, and then instead of writing milli, I'm going to write 10 to the minus 3. Remember, because milli just means times 10 to the minus 3 liters, and then the concentration of HCl is 0.053 mole of HCl for every 1 liter. That's what that uppercase M means. Uppercase M like that is the same as writing moles per liter. And so you can see that that does my first conversion, and now I am there. So now I'm going to use my mole ratio. So I'm going to multiply by mole of sodium bicarbonate over mole of HCl. And the numbers that go into my mole ratio just come from my balanced equation, and here they are. They're in a 1-to-1 ratio in this case. So that's nice and easy. And then finally, I need to multiply by So now I'm there, right? Because moles of HCl cancel out. Leaves me with moles of sodium bicarbonate. And then finally, I've got to multiply by the molar mass of sodium bicarbonate. So I need to multiply by grams of sodium bicarbonate in 1 mole of sodium bicarbonate. Now I can add all of that together. 22.99 for the sodium, 1.01 for the hydrogen, 12.01 for the carbon, and then 3 times 16 for the oxygen, and that'll give me my molar mass. So let's go ahead and do that. 22.99 plus 1.01 plus 12.01 plus 3 times 16. And there it is, 84.01 grams in 1 mole. The other alternative is to use a molar mass calculator, which I have one bookmarked. You want to use a legitimate molar mass calculator, and then you can just put in the formula and it'll calculate it for you. There we go, 84.01, the same thing. What I would avoid doing is doing this. And just Googling, because you may or may not get the right answer. So you can search, but you want to use a legitimate scientific search engine. Just to be confident. People got caught out in the objectives Googling molar masses. There's really not any need to. It's just as easy to use a legitimate search engine. Wolfram Alpha would be another one, wolframalpha.com. Alright, so all of my units cancel out. I always make sure all my units cancel out before I pick up my calculator, and then away I go. So now it is 150 by 10 to the minus 3 times 0.053. I don't need to do times 1 on 1, do I? Times 84.01. So I'm just multiplying 3 numbers together, and there I am, 0.6679 grams of sodium bicarbonate. I just recorded a few more digits than what I know I'm going to need. And I bet you it says round off to 2 significant figures. Round your answer to 2 significant figures, right? So that's going to be 0.67 grams. And there it is. Okay, I hope you found that helpful, and good luck with everything.